Thank you very much. It's a great opportunity to talk to you about IsoAcoustics and what we're doing. And also, we've recently been testing again at the NRC, and I'd like to share with you some of the results of that testing and hopefully pull this together so you can see what we're doing and how our products work. How many of you have heard, how many of you know of IsoAcoustics? Yes. And how many have actually heard it firsthand? Oh, wonderful. Thank you very much. If you don't mind, I'll just take a quick moment to describe my background and how this whole thing started. I worked for the CBC for 20 years. I guess the pinnacle of that was I had a role on the design team for the broadcast center. And that was, well, that was quite some time ago, actually. But this whole genesis with the IsoAcoustics didn't so much start there specifically with that project, but it was really something that I dealt with on my own. There was just a very quick story. The NRC did some testing for the CBC. They chose a set of speakers that were going to be put in all the radio studios. And I worked on, if anybody knows Studio G, the drama studio in the back of the radio building. These speakers were installed for the first time we heard them. I've got a pair for myself, and I had the opportunity to meet Paul Barton. And I was bringing home all this equipment. I was going to run pink noise and set them up, and when I talked to Paul, he said, I'll come around to your house and I'll set them up with you. So that night turned into a little bit of a speaker design 101. He spends a lot of time at the NRC and back in the Floyd Tool days, and he made a comment that kind of resonated with me. He said, the largest variable is out of my control. And I thought, bloody hell, I spent all this money on these speakers, and is he talking about components or construction or labor or what? But he was referring to how people use them, the placement, the position, and everything else. And this was the first time that I had an opportunity to actually move speakers around, set them up, see the graphs, hear the differences. And it's a little bit like a sailor learning, you know, how you're shadowed from another sailboat, you know, the headers, the lifts, the eddies off the shore. You begin to see all those reflections that are happening and how, as you move speakers around, it makes a profound difference. So I noticed there was nothing on the market that really allowed you to have that flexibility. And as I spent time at the NRC playing with isolators, I learned that if you actually sculpt them, you can manage how they respond to that energy. And that was really the genesis of this IsoAcoustics. So two of the largest studio monitor manufacturers wanted to license what I developed. I'd patented and gone through all this stuff. And we decided in 2012 to start on our own. We had one SKU at NAMM in January of 2012. Today we're in the pro audio side, we're in the hi-fi side, we're getting into live sound, and we have 50 SKUs, and we're selling in, we have distribution in 70 countries. So, thank you. So let me just walk through quickly a little background of what we see. Does this thing work like this? We'll do it old school. There you go, Fred Flintstone. So I like to start here. This is the control room for the Boston Symphony. WSDG did the renovation. They won a tech award for it. And John Stewart called and asked me if we would come down and install the Gaias under their B&W speakers. Now the Gaias are these isolators that screw underneath. The concept in the hi-fi side is you remove the spikes and you screw the Gaia up underneath. And we put them in place. They had about 6 people there from the Symphony and 6 people there from WSDG. We listened to a James Taylor song, and then we listened to a symphonic piece that they were working on, put the stands, the isolators underneath, stood them back up again, and even the people in the back of the room could just hear how the soundstage just opened way up. The sound was completely transformed. So they're really big fans of these things. They've worked really, really well. And the big thing is, I like to use this example because they have over 40 microphones and decatries over the orchestra. And now, as our late friend and Ed Marshall once put it, the phantom image is projected against a pane of glass between 2 speakers, typically. when you use the IsoAcoustics stand, somebody's opened the window, and now it's got depth, it's got shape, and it's got height. So when they're mixing in this control room, they're actually bringing up a track, and they can actually hear it in that three-dimensional space. So they've been very enthusiastic about the results of that. So it's dealing with time domain, it's dealing with isolation. It just works really well. When you think of John Stork, Eddie Kramer probably comes to mind. And I was a big fan of Jimi Hendrix. I saw Jimi Hendrix at Maple Leaf Gardens not that long ago. And so it was a great opportunity. It was a real privilege to be able to meet with Eddie Kramer in his studio. He was mixing some music, and he was working away. We just listened to some tracks. We put this is referred to as the ISO puck. We put it underneath the monitors, and he was shocked. I could just see his body language change as he heard the difference. Now, the thing I'll point out to you right now, those are ATC 25 speakers, and they're actually on sound anchor stands, on steel stands. So we'll come back to that point in a minute. But for those that think in terms of a good steel, strong stand it's probably as good as it gets, we'll talk about why the pucks work in that scenario. Chenzo Townsend's in the UK, and he does a lot of things like Ed Sheeran and so on, and he's a ISO user. Daryl Thorpe, Paul McCartney, and Foo Fighters and so on. Frank Filippetti. Now this is the original series of stands. This is the concept where there's 14 variations of height and tilt designed for near-field monitors. You can get them positioned so that the tweeter's right, the dispersion angle and the tweeter's in the right position. But just getting the speaker in the right spot is only half of the trick. It's the way the isolators work that really gives that openness and that clarity. Does anybody know this gentleman? Ian Terry, good friend. And in the early days, he actually gave me a hard time one day down at Humber College. We reviewed the speakers with he and some of the faculty, and I didn't really know where we were going. And then at the end of it, as we were heading out the door, he pulled me aside and said, "We're going to order 24 pair for the studios and the control or in the listening rooms and so on." So I was very pleased with that. But even beyond that, a big part of our development is looking to the golden ears, looking for people to validate what we're hearing. And Ian and that faculty has helped us on occasions to do that too. We'll get into that more in a second. And I didn't know if Rich was going to be here, but there's kind of a long-standing little joke behind this that I won't get into, but it has to do with a manufacturer in Scandinavia. But we'll move on. So in summary, what we're really finding is that the bass is tighter, there's greater clarity and openness, improved soundstage, and that three-dimensional image becomes more open and more spatial. There's really three things that you need to think about when you place a speaker anywhere. The first one, I think everybody understands. In fact, the first one, I think, is the reason why people think about isolation at all. And that is, are you exciting the supporting surface? In fact, people will say, listen, I've got a stand that's 8 inches of marble. You're not going to excite it, so I don't need your stands. The second point is structure-borne noise. You can be causing anomalies within your own space, and you can be causing problems with the adjacent spaces as well. So even a console can be excited, and that energy can move elsewhere in the space, causing acoustic concerns. But the last one's really the interesting one. And this is the reason why, even if you did have 8 inches of granite on your tabletop, you do need the stands. If we go back to the example at the Boston Symphony, when you put a speaker on a solid surface, there's an internal reflection that comes back up into the speaker. Think of it like bolting a piece of pipe to the wall, hit it with a hammer, and the vibration goes down the pipe and comes back up. That energy comes right back up into the speaker. It causes smear. And any artifacts of that are similar in both channels are perceived to be in the middle. So they cause the soundstage to collapse and become two-dimensional. So it's quite ironic, and all the time stereo sound has been around, we have two speakers, and you can swear that you can hear that singer right in the middle. That phantom image sits right in the middle. But the fact is, it could be collapsed. You hear an old Frank Sinatra record or something, you swear you could put your finger in his mouth, but it's collapsed. If we can get rid of those artifacts, clean up that smear, suddenly the soundstage opens way up. And that's the experience that they had at the Boston Symphony, that suddenly they've got a three-dimensional soundstage, and as they're mixing, they can hear it in that space. An example is you listen to a Diana Krall record, and she sounds like she's in front of the piano. She's not just in that collapsed soundstage. She's not in that phantom image in the center. Okay? So just remind you that steel, wood are maybe 8 to 10 times faster at transmitting energy than through air. So in the speaker itself and that connection to the ground, that transfer is happening far faster than it's moving through the air. So we go to the NRC. We've been there on a number of occasions, and we were just there recently this last July. And the first thing we always do is we go into the anechoic chamber, we take a speaker, a control speaker with spikes, and we do the plotting, and then we take all of our products and we substitute them and we look for the delta. And I'm pleased to tell you that we've confirmed that there is no delta. That in fact, if you went pass to pass with the spikes, we're within that change from one pass to the next. Now, if you're one of these people on the internet that claims, you know, I did all of these reviews and I don't see a difference, there is no difference. I mean, probably the most important tool or instruments on the side of your head, but we're not creating any colorization. If there was a difference, we'd be coloring, and that's not our place. We have to respect what the manufacturer's doing, and we can't influence in that in any negative way. We use a laser vibrometer. And the laser vibrometer looks at the front, looks at the baffle of the speaker, and we take many shots of that. We watch what's happening, and we can actually see the energy. We can actually see the speaker, those reflections back in the speaker. You may wonder what this crazy contraption is underneath. We test them on the spikes, we test them on the Gaia, but we've also created this platform that has the Gaias built in, and it has solenoids. And when we activate the solenoid, it lifts up off of the Gaia, and it simulates being on spikes. So the whole point is to try to stay within 1/4 of an inch, so you're staying within half a wavelength at 20K, so that we're not changing acoustically the sound, but being able to flip back and forth. But here's the results. Sorry. What we can see here is the attenuation down through the speaker. We can actually see how the stand is responding. We can actually see the attenuation down to the supporting surface. But here's the really interesting piece. The purple line is on spikes. Those spikes are sitting directly on the floor. And those artifacts that I was describing to you that are coming back, we can actually see them as that disturbance within the speaker. And you can see that the IsoAcoustics stand has attenuated that down, has brought it down, and so we've reduced it greatly. A lot of people think isolation only deals with the very low frequencies, but I think you'd be surprised to hear that it goes all the way up through the entire audio spectrum. But the question is, we know that inside of a speaker there could be lots of resonance and lots of disturbance anyway. It's like a storm in there. So how do we try to determine what is based on that boundary condition being placed on the floor and what is inherent within the speaker itself? And so we have a rig that puts the speaker up on bungee cords. So again, we're trying to maintain the same height, the same level again, but now we've broken that connection with the floor so we don't have that direct reflection coming back, you know, the pipe bolted to the wall. So we've gently lifted it off the wall, if you like. And this is a result of that. So you can see the blue line at the bottom is significantly lower, very similar to what the IsoAcoustics stand has done, but it's brought that disturbance way down. So you can see we've come a long way to actually eliminating the effect of that boundary condition underneath. But anybody who's ever heard a speaker that's just floating in space, it really sounds like crap when it's on the bungee cord. And you know, the big fear is that when you have a speaker and you allow it to move, when the cone is moving forward and the cabinet's moving back, the net result is less than what it should be. And isolation got a bad rap years ago because when you only isolate something vertically, you can allow those changes to happen on that horizontal plane, and typically you lose bass. But our design, sorry, I'm always rushing ahead, I'll slow down. This refers to that boundary condition again. So if you have spikes on the floor, the closed boundary condition, the wave hits and it returns. It's the inverse wave that returns back. When you create some isolation at the top, you can attenuate that back, and that's why we're mitigating those disturbances coming back up into the speaker. This is what I wanted to say. Here's how all of our systems are based. They're based on 2 isolators, and there's a connector in between. If you use a single homogeneous material, it has a limited range of which it can work within. But by creating those 3 components, we can actually tune them. And we use shape, thickness, and geometer to tune them for that shape. So every isolator we have has an empirical curve. It has a performance curve, if you like. And we can manage that. We can change it. So if you look at our different products, they change in size. Even things like the concave shape acts as a progressive rate to help us make that, to alter that shape, alter that curve. So we've got the vertical isolation, but also because of the shape, because of the shape of those isolators and the insert that's between them, we manage how they respond. And we bias them so that they have a direction. So we always tell you to install them with the logo facing forward towards the listening position or 180 degrees away. Because they're designed not to go laterally to resist lateral movement, otherwise they would begin to bobblehead and they would begin to oscillate. So the big thing to keep in mind is you can create isolation vertically. You can use a homogeneous material and create isolation vertically, but to me it's a little bit like, you know, tying a machine gun onto a beach ball. You can create isolation, but you don't have any control. If you create an assembly that actually has direction and has control, you can manage that. And that's where that clarity and focus comes from. So when we're finishing a product, when we're finalizing the molds, we go through this testing, A/B testing, this blind testing back and forth, and we refer to it as bringing them into focus, where you can actually hear through the different variations where they're, just how they're sitting within that curve overall. That's what I was referring to with Ian when we went down to Humber and finished off some testing. I brought down some examples and asked them to point to the one that they preferred. Yeah. So I'll just go quickly through the products just to give you an idea of what we've been, where we're going here. This is the Gaia series. Typically, they're for the hi-fi market. You remove the spikes, you screw them up into place. This is all based on 4. So you remove 4 spikes. Gaia 1 is for a speaker that's up to 220 pounds. Gaia 2 is 120. Gaia 3 is 70 pounds. And if you have a heavy carpet, we also make a carpet disc that goes through to give it a good, firm foundation down below. This is the right application for spikes. Spikes are really intended for carpets, and they've mysteriously found their way to become de facto on the hi-fi side. You know, on the pro side, we think about steel and heavy stands and mass, and on the hi-fi side, they're like spikes. So this is new alternative. It's funny, I think of what we're doing as like tire designers, like Formula One tire manufacturers. Nobody criticizes Enzo Ferrari because he needs tires, but the tires complement the car. And oftentimes you find manufacturers get a little bit funny because they feel it's almost a criticism of their design, which it's not. We're just dealing with that boundary condition, that interaction with the supporting surface. So we're building a larger series of Gaias. They're coming out this fall. It's called the Titan series, and we're going up to speakers that are 620 pounds. So if you've seen hi-fi speakers that are 620, like the Martins and the Focals and the Wilsons and so on, we're covering off all of that range. In fact, we've got a video that's coming out. If you know Michael Romanowski, he's a mastering engineer in San Francisco, and he has very large Focal speakers, and we're doing a video with him about just what the stands do and what mastering is and what the stands do to complement his speakers. This is the ISO series, and this was just regentrified this year. The original series was the Isolator series, and this just came out starting in January. We announced this at NAMM, and these are the ones with the height and tilt adjustment, 14 variations of height and tilt. And this is the Aperta series, which is cast aluminum. They perform a little better because the frames are more rigid, more solid, but again, you've got a tilt system there. The ISO puck, this is what you saw under Eddie Kramer's speakers. And I see this as kind of like the Swiss Army knife for the pro side. You could put them under guitar amps, mic stands, whatever you please, stage monitors or whatever. It's still the same idea. On the hi-fi side, we've got the Aurea, and they're stainless steel. And besides looking a little prettier, the curves are a little bit narrower and they're a little taller. So the performance is taller, but they work over a narrower band. The top flange acts as a suction cup to connect to the speaker. The bottom flange connects to the supporting surface, and all the energy is managed within. Okay? The principal application for this is hi-fi components, turntables, and things like that. Can be used for speakers as well. The modular system, we've got an example on the table out there. It could be built any size, and it's based on weight and size of the speaker. That rig over there is a sound anchor stand. What do they call it? Mid-adjust, mid-add. And sound anchor will actually add that steel plate and drill the holes so that the IsoAcoustics frame could be built in it. This is Steve Vai's cabinet on the IsoAcoustics stand, and this was taken during that last album we did, that Passion and Warfare, that was done a year or so ago. And the stand, as I said, could be made any size, any configuration, and integrated as well. And this is new. This is OEM now. We're talking to manufacturers of furniture, studio monitors, speakers, and they're looking to integrate these into their systems. So this simulates the bottom, and they just get screwed into place. Those are the weight limits for each of them. And so in the new year, I hope you're going to find that there's a whole group of manufacturers that are starting to incorporate the IsoAcoustics directly into their products. Okay? And then lastly, we've got a new product that's coming out now. It's called Stage 1. It screws up underneath a cabinet. It could be used under subwoofer, guitar amp, bass amp, whatever you please. Or you could put it directly underneath a piece of plywood and use it as a platform for those things. So we made up a stand for John Mayer. There's a copy over there. Eric Johnson, if you're familiar with him, he's got it. Steve Vai. So we're getting feedback from them as well. That's going very well. So the big thing here is when you go from one gig to the next, the stage is a big variable. They can act as a huge drum. And now you've got a consistent surface that you're working on. Just makes that sound check so much quicker, right? And that's our story. So finally, we just opened a new office right on Main Street in Markham. If anybody is nearby, please drop in. We've got a setup there where you can demo back and forth. We've got a pro audio setup as well. And there's also a show in Toronto next month, hi-fi show in Toronto. And if anybody can get out there, we'll have a demo set up there and you can hear it. And it's a great opportunity just to be able to hear it back and forth and just A/B it and hear those, the differences that I was describing. Okay. Thank you very much.
Thank you so much, Dave. That was great. Thank you.
Good. Thank you very much.